The Invisible Push, Story of Coulomb's Law. Hi friends. Welcome back to Electrical Online, where we turn science into unforgettable stories. Today, we're diving into a law that explains why charges attract or repel, why electricity moves the way it does, and how the invisible push and pull of energy works. Get ready for the Coulomb's Law, the law of invisible forces. But instead of boring equations, let's turn this into a magical story. The story of Chargeville, the land of charges. Long ago, in a floating world called Chargeville, lived two types of tiny glowing beings, positive charges and negative charges. The red-colored positives were always energetic, while the blue-colored negatives were calm and grounded. The most important rule in Chargeville was, opposites attract, and like charges repel. Whenever two positives or two negatives got close, they pushed each other away. But whenever a positive and a negative met, they were instantly pulled together. Like best friends reunited. The people of Chargeville lived by this strange invisible force but didn't understand why it worked, until a wise old scientist appeared. The scientist behind the law, Charles Augustin de Coulomb. In the real world, this law was discovered by Charles Augustin de Coulomb, a French physicist. In 1785, in France, Coulomb conducted brilliant experiments using a special tool called a torsion balance. He noticed that charged objects either attract or repel depending on their type, and the force they feel depends on how strong the charges are and how far apart they are. This became the world-famous Coulomb's Law, which helps us calculate the electrostatic force between two charges. Definition of Coulomb's Law. Coulomb's law states that the force of attraction or repulsion between two-point charges is directly proportional to the product of their magnitudes, and inversely proportional to the square of the distance between them. Mathematically, F equals K times Q2 divided by R square. This law explains the strength and direction of electric forces between any two charged particles. Derivation as a family story, understanding the formula. In Chargeville, the ruler was a mighty king named F, the king of force. But his strength didn't come from muscles, it came from his family. He had two powerful queens, Q1 and Q2, both were full of electric energy. The stronger these two queens were, the more powerful the king became. Their bond, shown as the multiplication Q1 times Q2, gave him energy. Beside them stood the loyal and unchanging royal guard, K, who made sure everything was fair and in balance. He represents Coulomb's constant. But their naughty son, R, always created problems. The farther the son went from the family, the weaker the king became, not slowly, but by the square of the distance R square. If the son doubled his distance, the king's power became 4 times weaker. That's why the strength of the king was always written as F equals K times Q1 times Q2, divided by R square. A perfect equation made of a family's bond, a soldier's discipline, and a child's distance. This simple story helps us remember that more charge means more force, and more distance means less force. Formula explained in simple words. The mathematical form of Coulomb's law is F equals K times Q1 times Q2, divided by R square. Here, F is the force between two charges, in newtons. Q1 and Q2 are the magnitudes of the charges, in coulombs. R is the distance between the charges, in meters. K is Coulomb's constant, 9 times 10 power 9 nm square divided by c square. So, the closer the charges, the stronger the force. The greater the charges, the stronger the force. And if the distance increases, the force drops rapidly. So now you know, Coulomb's law is not just a formula, it's a story of balance, distance, and electric love. From the smallest atom to the tallest lightning bolt, this invisible law is working every moment to create repulsion, attraction, and motion. And it all started with one curious scientist, one clever formula, and one kingdom of tiny charges. If you enjoyed this story and want more fun explanations of deep electrical concepts, don't forget to like, share, and subscribe to Electrical Online, where every equation becomes an adventure.